Hello guys, how are you? For this lesson, I will be covering our analytical geometry, and I'll be looking at some key aspects of this topic. Firstly, our ability to use the equation of circle with the center at the origin and with the center not at the origin. This is the kind of stuff we sort of talked about on our initial introduction to the topic. And you should be able to do those kind of things. You should be able to understand your relationship between the radius and the tangent, that the radius and the tangent are perpendicular to each other. That's another key property that will work for you when solving these kind of questions. Also, you must be able to relate the distance from a point that's on the, obviously, you know the distance from a point that's on the circumference and the center of a circle, that's your radius. But sometimes you have a point that's outside the circle, and then you should be able to relate if that point will be joined to another point that's on the circumference of a circle, and that being the tangent to the circle, and be able to find the distance of that line or the tangent line that touches at the circle using the theorem of Pythagoras. We'll kind of cover some of those things here, and we'll look at the intricacies of these and this particular topic and what is it actually that you're supposed to watch out for. But mostly, as we go ahead, you will be able to see another thing. Before I forget to mention, is your ability to use completing a square of the or maybe your ability to complete the square of the equation of a circle with the center that's not at the origin, in order to find the center. Sometimes, because you may be given the equation that is not in the form x minus a squared plus y minus b squared equals r squared. And in that way, you should be able to write in that form. Just like when you complete a square, to move from the y is equals to ax squared plus bx plus c general or standard equation in your parabola or your quadratic function, and then moving into y equals a into x minus p squared plus b, which is your vertex or turning point form. Kind of more like that here, but obviously the equations are different, but same ideas. Now, another thing that we will look at is, again, I did talk a little bit about the properties of the tangent and the radius. Another thing we should be able to do is being able to calculate if the circles do intersect or circles do not intersect using the properties of the radius. Now, if you find that two circles intersect, just like in this case, for example, if we're trying to find if two circles do intersect, you'll find that the distance between the center of the circle to the circumference and the center of the circle to the circumference will be obviously their respective radius. Now, or respective radius. Now, the idea here is, you give me a second. I need to drink some water. All right, I'm back. I would say the idea here is when you have the circles that do intersect, like in this case, say the line from the center of the circle to the circumference basically is this smaller circle's radius, and the line from the center of the circle, probably here to at C. We're gonna see as we proceed with the question. Now, the line from the center of the circle to the circumference will also be is a radius. So now taking the two distances of the respective radius, if the distance happens to be smaller than those radius added together, we know that the circles intersect. If it's a little bit larger, if the distance is larger than those two radius, the circles do not intersect, and if the distance basically between the two radius is smaller. In order to find the distance between the two radius, we just have to take the center and the center and just basically calculate the distance using the distance formula. Remember, guys, this is the analytical geometry topic, so your distance formula will come very handy, just as your midpoint formula and your gradient formula. So we'll be specifically looking into those formulas. Now, also given the formula for the circle, equation of a circle with the center of the origin, and there we go. That's right down there. Now, let's go ahead and just take a look at the equation. Now, before we take a look at this equation, some of you must be interested in our classes, or maybe to just get into contact with me. Now, feel free, go on inbox and just maybe if you want any information in terms of how actually do I schedule my class, where and when, and what prices those classes are. I'm not gonna share that information here to you guys, but you can feel free to just inbox me on with these, and I'll be able to just give you that information as you may require. Now, for our classes, the weekends, the Komela A Banguna High School. It's actually here in Gongoa. Banguna High School. It's actually near Bethesda. Now, I'm sure that you guys know what that is. On the second class on the left was we've been to the school premises, and then with the blocks, actually the second class on the left. There's the first block. On the first block, there's first class, second class. So that's A2 class, and that's what you can find us on weekend, or you can just contact me. I'm not on WhatsApp. I'm actually on WhatsApp, but not busy on WhatsApp. But if you do want this kind of information, I'll be glad to respond to you. Okay, so my number is 060-905-8861. Feel free to hit on that number, and you can also use the same number for calls, and I will be quick to respond. All right, let's go ahead with that being said. Number 3, they're saying we actually had a couple of questions here. I skipped this one because this is a basic quadrilateral, so I didn't want to talk about quads. I actually wanted to focus on circle. But quadrilaterals, your kites, your rectangle, parallelogram, rhombus, those kind of shapes are very useful to know their properties. But we'll talk about that some other times. Here, I just want to strictly focus on a circle. All right, so in the figure below, number 3 reads, T is a point. Now, that's the T here in the middle of this large circle. Is a point on the x-axis. So now that point is right on the x-axis, as we can see. A circle having T. Now, I want you also to pay attention to that, what they just said about T being a point on the x-axis. Now, again, they continue to say a circle having T as a center intersect a circle having N as a center. So the N is 2 and 3. The T circle is actually not given a center. So basically, we just know it's a T. And by the way, if it's a T, we know the Y here is going to be a 0 because T here, they said, is a point on the x-axis. So it's basically the x-intercept here. So your Y is going to be a 0. So pretty much we know what the Y is here. We just don't know what the X coordinate of the center is. Which saves some time, but sometimes if we can figure out, if we know what Y is, we can pretty much figure out what X is. I think if we can actually find the equation of this line, we should be able to do that. And so we have the point P on the circumference of, let's just read that. A circle T and its center intersect a circle having N, which is 2 and 3, as the center at P. So they intersect at P. So our point is the circumference of the small circle, and also they intersect at M. So there are 2 points of intersection, all right, of the two circles. Now, if we find maybe the equation of this graph, we should be able to equate with the equation of that graph. We'll see what those points are for x's and y's respectively. All right. Now determine the equation of a circle and the smaller circle, this one, in the form of x minus a squared plus y minus b squared equals r squared. All right. So getting ready to do that, that will be our first equation. Now remember, if we're going to solve an equation in the form of a minus x minus a squared plus y minus b squared equals r squared, we're going to need a few things. We're going to need a and b. Remember, a and b are the coordinate of the center, right? Which is 2 and 3. So we're gonna just place there 2 and 3, and we'll be good to go. So that will be minus 2 and squared plus y minus 3 and squared is equals to r squared. Now, that will find the point 2 and 2 and 3, which is the center. We'd now want to find the radius of a circle. In order to find the radius of a circle, we should substitute the point P, which is a 4 and 5. Now, substituting the point P, which is 4 and 5, to this equation, we should be able to find the radius, all right? Because the radius is the distance, if I may. The radius is the distance from the center of a circle, the smaller circle, to its circumference, to the point on its circumference. Basically, we use the distance formula because this does look like a distance formula. It says is the distance for this square. We just basically use the r squared, and so we substitute our point in order to find the distance. So let's go ahead and do that. So the x is going to be a 4. Then we subtract a 2. The y is a 5. Excuse me. Equals r squared, and then 4 minus 2 is a2, and then I'm going to square that, and 5 minus 3, that will be again a2. 2 squared and 2 squared, that will be 4 plus 4, which is r squared. So r squared is going to be an 8. Now that I find my r to be an 8, I do r squared to be an 8. I don't have to necessarily find an r, but if you're interested to find an r, that will be the square of 8. And the square of 8, I think, is going to be 2 times 4. 8 is a 2 times 4. 2 times 4. And the root of 4 is a 2. So the r will be 2 root 4 if you're looking for r specifically. But we do have the r squared. I'm just going to substitute the r squared as it is on the graph. Okay, now, the position of r squared, I'm going to put this. So my equation will be x minus. Remember to rewrite your equation with the x and the y. It's going to be an 8. So that's the equation of circle with the center at n of 2 and 3. Now, I think we're going to, at this point, go to the next question. All right. Let me just highlight that so that we can see what the question requires. All right. The second question says, hence, rewrite the equation in the form. They want us to rewrite the equation in the form, in that form. So remember, our equation is the x minus 2. So they want us to rewrite it from a squared plus bx plus cy squared plus dy equals e. Now, the a and the b and the c and the d, obviously that e is just going to be some constant. Those are constants, all right? Now the a is a constant that is a quadratic of the coefficient of the quadratic x, and the b is the coefficient of the linear x, and the c is the coefficient of the quadratic y, and the d is the coefficient of the linear y, and e is just a constant. So now remember, when we have an equation like this, now mostly it's coming from the equation that looks like that. Now, what we did to that equation mostly, I think you remember at the start of this topic, we were having some questions that had to do with finding the equation that was written, the equation of the circle. And they wanted to us to find the radius, to find the center, but the question was given in more of this form. Okay, so what we did there was to just take this form and complete the square to get there. So this is already an equation which, I can say the square is already completed. So we just, in other words, they want us to work us back to work this equation, the x minus 2 squared plus the y minus 3 squared backwards, in a sense, if I may. So in order to do that, we can say decomplete the square, because here, obviously, the square was completed. So we just have to do the binomials. And then after doing the binomials, we'll be able to see what we do. Okay, so now the x minus 2 square binomial has to be expanded. So we are sort of kind of writing this in an expanded form, if you may. So it's going to be x squared, minus 4x minus 4x and plus 4 plus, that's going to be y squared minus 6x plus a 9 equals 8. So on the right side, I simply have an 8. So what I need to do is you can see these constants are not here. All right. If you look on the left side there, the constants are not there. So what happened is that the constant was subtracted on the left-hand side as well as on the right-hand side. So for me to get rid of them, I need to subtract this constant 4 and that constant M9 in order to get rid of them on the left side, presuming that I've also subtracted them on the left side. Okay, so in other words, now the next line of that equation will be where I have to write x squared minus 4x and then plus y. Remember, I get rid of that. And then it equals 8 equals 8 minus 4 minus a 9. So we're going to take 8 minus a 4 minus a 9. Calculator should tell me what the solution that is. So 8 minus 4 minus 9, that's going to be a minus 5. Remember, the minus 5 there is not a radius. 8 is a radius, but the minus 5 is just some constant number. And when we complete the square, we should be getting the actual radius. So here, I'm just going to put a minus 5 instead of an 8. All right. Now that we're there, I think we were able to write the equation in the form that they wanted. Now, if this is correct, what we did right here, on x squared minus 4x plus y squared minus 6 equals minus 5, we should be able to work it right back by completing a square and get this exact equation. All right, so the coefficient of the quadratic x squared is a 1, and the coefficient of the linear x is a minus 4, plus the coefficient of the quadratic y squared is it's a 1 actually also, and the d is a minus 6, and the e is a minus 5. All right, so now they're saying also, hence number C, this was number B. This was letter B, excuse me. And the first one was letter A. Okay, so on the letter B, they're asking you also, hence we write back in that form. So like I said, if we did ensure all your workings, if we did work it right, we should be able to get the exact equation that we had initially of x minus 2 all squared plus y minus 3 all squared equals 8. Now, that shouldn't give us a problem at all. All right, so now I'm just going to go ahead and do that. That's letter C. So I'm going to take this equation in this form, which is x squared minus 4x plus y squared minus 6x equals a -5. Now, I should complete the square in order to get to that, right? Mostly, when we're working the activities in the class, we had our equations more like that, and then we're supposed to complete the square to get the correct equation. All right, let's go ahead and do that. So we're going to have x squared minus 4x as, now remember we had to add the constant coefficient of the linear and half it or multiply by 1/2 and then just basically square it. So that's going to be that. Then we divide that by 2 and square it. Dividing by 2 is more like multiplying by 1/2 and square. That's called completing the square. We're going to complete the square for the y as well. This was supposed to be a y, not an x. And then 6y. And then what I'm going to do is I'm going to add the -6 and then half it and then square it. Remember, it's equals to -5 plus. I have to do the same thing on the right. I'm kind of running a little bit out of space there. Let me just do this. All right, and then I'm going to do the same thing. So a -4/2, I'm going to have to add that as well. So -4/2 all squared plus, I'm going to just squeeze the other one, -6/2 also squared. All right, so this should give me the x squared. The -4 divided by 2, basically, it's going to be a -2 squared. And -6/2 is going to be a -3 square that too. So it's going to be a -5. Now those numbers are going to be those numbers, but obviously with the positive, right? So a -4, I'm just going to do the same here. It's going to be -2 squared plus -3 squared. Now, remember, negative integer squared, basically it's going to give us positive integers. Now here, I want to just highlight for you something. What you need to do is avoid giving a square of a -2 and giving a square of a -3, right? Because now, if you give that as you can see here, obviously it's what do we call that? I think it's a 4 and a 9. You still have to factorize this to get to this point. So what I usually suggest for you to do is just take this quadratic, this one right here, and the quadratic right there with their sign. So that quadratic is going to be an x, and then this one is going to be a -2, and then put them inside the brackets and square them. That's basically you factorizing this trinomial expression or a perfect quadratic. And then also you do the same thing there. And then that's going to give you a -5. On the right hand side, by the way, you just have to just do these numbers. -2 squared, you can take it out. So we're not trying to factorize. It's going to be 4 plus, and that's going to be a 9. All right, so we have x -2 squared plus y -3 squared equals the -5 plus 4 plus a 9 should give us an 8. As you can see there, it's an 8. So we're actually able to work our equation back into that form, showing all our workings. They should be able to award. Unfortunately, here we don't have mark allocation to this, but they should be able to award you full marks for that working. Let's go to letter D. The part D of the question says calculate the gradient of PT. Right. Now, what exactly is PT? You can see here the PT is this line here. PT as that line is the gradient of the smaller circle, the circle with the center at end. All right, so if it's the gradient of the smaller circle, we should be able to find the equation of, were they looking for the equation? Let me just check. Calculate the gradient, or they're looking for the gradient of PT. We should be able to get the gradient of that using the property that the gradient of NP multiplied by the gradient we know There's a perpendicular line, NP, and NP is perpendicular. I'm sure they did say that information. Let's just go and look up. Or they didn't mention that, but I mean, we know that NP and PT are perpendicular to each other. So NP is perpendicular to PT. So if they're looking for the gradient of PT, we can actually get the gradient of NP because, I mean, NP is a radius. Now, we'll multiply that by the gradient of PT, and the product should give us a -1. So let's find the n of NP, because that's actually what we have. So that's going to be the y-coordinate of P minus the y-coordinate of N divided by the x-coordinate of P minus the x-coordinate of N. Remember, you can start with N and minus the coordinate of P, whichever way it works out. So remember, let me just write the coordinate of those points. So the coordinate of N is the center, which is 2 and 3. However, the P is the point of the circumference. I think it was 5 and 4 or 4 and 5. Let's just, okay, it's a 4 and 5. So it's 4:5. So the next thing that we're going to do is basically to put those points in their respective places. The y-coordinate of P is a 5. However, of N is a 3. I'm going to subtract that. The x-coordinate of P is a 4. However, the y-coordinate or the x, of x-coordinate of N is a 2. So there's going to be 5 minus 3, which is basically 2, and also a 2. So the gradient of NP is a 1. So now again, taking the gradient of NP, multiplying by the gradient of PT, we should get a -1. The gradient of NP is a 1. So I'm going to multiply by the gradient of PT. The product should give me a -1. So in that case, I'm going to divide by 1, divided by 1. 1 and 1 cancel. The gradient of NP, PT, is equals to a -1. So the gradient of PT is equals to a -1. Now we're done with that. Let's take some more questions. Number letter E and letter, because I stopped on D. So I'm gonna go for E, F, and G, and we'll see. I'm not gonna be able to take all of these questions because they're kind of long. Yeah, I think they start at N. I'm gonna make sure that I give you guys the rest of the questions for your homework. And on the next lesson, we may be able to just take a look at what we should do to get ahead and what kind of mistakes you guys made, kind of challenges that you come across, and just feel free to just basically get into contact with me. My email address is Tariq @Imhotep@Yahoo. Basically, it's T for T and A for the first letter of the alphabet, R for rice, and then I for ice, and then Q for queen. And then just no spacing, just immediately write an I for ice again, and M for mother, and then H for hot, and then O for orange, and then T again for tea, and then E for elephant, and then we'll also have a P for pie, and then at Yahoo. Now that will be my email address. So be sure to hit me up on an email, and also I'll be sure to just get into contact with you if you're interested on my private one-on-one classes. And then we'll talk the logistics of how that will work out. Right. I do have learners that work one-on-one with me, and they've been actually, what I want to do is I want to actually do a Zoom seminar just to kind of talk to these guys that I've been working with, these learners that I've been working with, and how they've quite improved. And some of them, I had them last year and they were in grade 11. Some of them I just had them this year, but they quite had a tremendous improvement in their grades. since they've started working with me. So I kind of hold that reputation. So if you're interested in upping your grades, you can hit me up. I'm your guy. Now, proceeding to, like I said, we'll take the part E to let's say to part G, the questions. And we'll take it off from there. Now, here they say hence calculate the coordinate of T. Now, they had us find the gradient of PT, which is the gradient of this line. So the gradient of PT is a -1, that line right there. So the next thing they want us to do is to find hence. With that being said, when they say hence, is with the already calculated information with the information that you've already calculated, you should be able to find the next question. All right, it should be easy for you to do that. However, if you didn't calculate that fast, you would then have to calculate it fast. So in order to find the equation of a circle, of a line, you would need to find the gradient fast and then substitute a point, and then you'll find that. So we did already find the equation of the gradient, of the tangent PT, which is a straight line. So the equation for straight line will be given by y is equal to mx plus a constant c, or y minus y1 equals m into x minus x1. Now, both of those equations will work out to get what we want. So the next thing that we're going to do is, now that we have the gradient, we should substitute the point. Tangent as just one point to the circle. We should substitute that point, and we should know what the equation of that is. All right, so I'm going to just do that. So it's going to be y equals mx plus c part E. Remember, the gradient is what we just calculated. Here we write the gradient of the tangent PT, not the gradient of the radius, because the line that we're interested in is the tangent line PT, which is a straight line. So the tangent is a -1, and then we'll multiply by x plus c. Remember, we can't write -1 as a coefficient of an x. We're just going to have -x. That's a constant c. Now that we have a -x plus constant c, we need to then substitute. We need to then substitute the point. Remember, the point that we substituting here is a t, which is a 4.5. It's a p, excuse me. So for y, I'm going to put a 5 equals negative. For x, I'm going to put a 4 as a constant c. So the 5 equals a -4 plus c, and then in this case, 5 plus a, 4, excuse me, should give me a c, and you see is a 9. So the constant is a 9. In other words, now that I have the constant, I should be able to do what I need to do. So the y equals the -x, that's our constant, 9. So we do have that equation. Remember, again, your y minus y1 equation equals m into x minus x1 should also work, meaning y minus the y1 is this point right here, which is a 5. And then equals the gradient is what we had, is a minus, and then x, the x1 should be the 4. All right, so x minus 4. Now that equation right there also does work for you. So you can just write it in that form and it will be fine. Now, if you leave it like that, it should be able to give you the full mark. Now, the next one says calculate the length of PT and leave your answer in a simple set form. Remember, PT will be the distance. So if we're looking for the distance PT, that will be PT squared. We'll look for x coordinate of P minus the x coordinate of T, and then we'll square that, the y coordinate of T, P, excuse me, minus the y coordinate of T, and we should also square that. That should be the distance. This is the distance formula, guys. Now, I know some of you guys are used to just saying PT equals x coordinate of P minus x coordinate of T, all squared, plus y coordinate of P minus y coordinate of T, also all squared, and having the square root just like that. Now, I'm not particularly fond of that because, just like you've seen, technically, I find it difficult to just write the square root out. Some of you use a ruler, but if you did this and that would be fine in both cases. All right. Here I just squared it. I will likely put the square root when I get to the last part of the equation. Let me just okay that. All right. So now I have to have the coordinate of P and T. The coordinate of P is a 4 and a 5. I need the coordinate of T. All right. Now this one's going to be a problem. A little bit of a problem, but not that much of a problem. Okay, we've already said that, like, as you've seen, in order to calculate the distance, we need the coordinate of the 2 points, which is that and that. Because since we're interested in the distance between those 2 points, which is this one right here, the distance. Since we're interested in that distance between those 2 points, we'll need the coordinate of each individual point. However, the x coordinate of that point we do not have, but we know is an intercept of the circle, of the line with the x-axis. All right. So it means that y is going to be 0 there. So actually, we're told that that point T is an x-intercept. So the point on the x-axis. So it's an x-intercept of the line graph, which we already have its equation, with the line graph with the x-axis. So now I'm gonna go and find that line graph, the one that I just did here, this one, and have the coordinate of the, what do we call it? The coordinate of the x of that point. All right, so that's what I'm interested in. So that equation was y equals negative x plus n9. So I'm looking for the coordinate. Now I have to let y equals 0 since I'm looking for the x-intercept. So I'm going to have negative 0 plus 9, in which case x is going to be n9. So the x is going to be n9. So that point T will have 9 for x and 0 for y. So I'm going to put a 9 and a 0. Now, looking at the structure, basically, of course, this is not drawn up to scale, but we can kind of see where we're going with this. Now, since about here, we have a 5, it will make more sense that at some point right there, we kind of just move 4 units. Now, considering the fact that from also here we have 4 units of the circle from the center. Now again, like I said, this is not drawn up to scale, but the equation has given us that the point is a 9. That point is a 9. So we're going to calculate the distance, the PT squared. The x coordinate of G, we do have it, it's going to be a 5. A 5, I'm going to subtract the 9 plus, and the y coordinate of P is a 5. So that was a y, excuse me. It's a 4 actually. So I have a 4 minus 9. And then I have a 0 minus 5. Yes, that's correct. Okay, so that's going to be a 4 minus 9. That's going to be a minus 5 squared. Plus, that's going to be a 5 squared. So it's going to be a 25 plus 25. That's going to be 50. All right, so that's going to be PT squared. Now, at that point, like I said, I'm just going to square. Distance is negative. It's never negative. So we're not going to use plus or minus for the root. So root of 50. I think root of this will be 2 multiplied by 25, as we can see here. It's just basically 25 by 2. So the PT will be root of 25 is a 5, but root of 2 is an irrational root of 2. So I'm going to have 5. Like they said, I should leave my solution for my final solution in cell form. So that will be 5 for 2. All right. Now, the next one that says, hence write down the equation of a cycle with the center T. So now I have the center T. I should find the equation of a circle. Remember, the point P is also on the circumference of that circle. All right, so the radius should be from the center of T, which is a 9 and 0, and the P will be the point of the circumference. The P again, which is a 4.5, should be the point of the circumference. Now, since this is my center or the T, I should also be able to find the equation of that circle, given the center and the point of the circumference. All right. So it's going to be x minus a. Remember, the center is not at the origin. So x minus a squared plus y minus b all squared. That should equal to r squared. So x minus a, the a is this one. So it's going to be x minus 9. And then y minus 0 squared. Remember, I said for the y, it's just going to be a 0. Hence, I'm going to have an equation that looks like that. Since for the y is going to be a 0, I'm going to have y squared equals x squared. Now that I have that, I need to find the value for the r using that point, substituting that point again. So that's going to be 4 for x, and then I'm going to minus a 9. We've already done that, kind of. So I'm just playing around here, but you should be able to be getting 5 root 2 as your radius. All right. So 4 minus 9 squared plus, that's going to be y squared is equals to the r squared. There, if we, so that's going to be r squared. There, if we substitute the y there, what is the y? Is the 5. So I'm going to just put 5 here. 5 squared, which is 25, it's going to be r squared. So here is going to be a 5. Negative 5 actually squared plus 5 squared, which is a 25, should give us an there squared. So we'll basically substitute the value for x and y of p, which is our radius. Now, that was a hands question. I was deliberately doing this so that I can illustrate something for you guys. Okay, so this is familiar. We just did that. So the r squared was 50. Basically, the r was 2 or 5 root 2. So that's our radius. Now, that's why they said hence. See, when they say hence, they don't want you to do all that work because it's already been done above here on the previous question. So we also already have the radius. So that when they say hence, you're not supposed to do all this work right here. So I was just kind of doing it just to illustrate to you guys that's going to be the same thing, because finding the radius is the same as finding the distance between the center of a circle to the circumference. And that's the exact distance they ask us, PT, but they didn't ask us in the form of saying that it's a radius. So your PT is actually of the radius, which is basically the point from the center of the circle at T to the circumference at P. All right. So now that we have the radius, all we need to do when they say hence, all we need to do is just basically to write that equation as x. We know the center is at T, and then y squared. And then for the radius, we're going to put 5 root 2, and then we're going to square that. 5 root 2, and then we're going to square that, just like that. That will be our equation of a circle. All right, now we're going to stop here for today, and then we'll be sure to take more questions as we proceed. Now, I will link the rest of the question for you guys to be able to find that along with this video. Now, with that being said, good luck and enjoy studying.